All right, well, again, I'm Chase Bernard. I'm the GIS coordinator with the town of Chapel Hill. You'll have to forgive me, I didn't really bring my A game today. Our power at home went off about 4 a.m. last night. I've got a 14-year-old and an 11-year-old at home, but no Wi-Fi. So I think things are ugly. Anyhow. All right, and my co-presenter, Dave Allman, who really did a lot of the heavy lifting on this project, was also not able to make it out. I don't know if he has Wi-Fi or not, but anyway, I will do the best I can, and some of the modeling and such that we did was really his work, but I'll kind of give you an overview, and if you have any questions, I'll try to answer them. If not, we can get him in touch with you. A little bit about this project. This is within our stormwater management program for the town. We've identified a number of volunteer citizens that have basically given their time to go out in the field and observe and take some measurements on some identified stream segments within the town, ones that are threatened, ones that we're trying to keep an eye on. And the real value in this project is that this is a recurring, ongoing project where they go out at least once a year, sometimes twice a year, and take a bunch of measurements. They can take pictures, and the project at this point is really in a pilot mode. We just got another round of volunteers to go, so we're still in the getting off the ground phase. But so far, things seem to be on track. So again, this is more of Dave's in stormwater, so he knows more about the details of the program, but that's kind of the overview. All right, let's see it. Okay. So this is an example of some of the forms that we've used in the past. Our stormwater folks are very thorough. They're splitters, not lumpers, so there's quite a bit of data here to collect, several sheets. So there's a good bit of effort to get this stuff on a clipboard and go out in the field and collect it. So our goal was to try and kind of mobilize and automate this process, make it as easy as possible to get the data from the field into our database on the back end without having to overly complicate the collection process. So we essentially took these forms, created a table within our database that collected all this information, generated a bunch of domains so that where we could, we would use drop-down menus and minimize the amount of typing that the users would have to use in the field. Okay, so before we get to that, one of the biggest challenges that we discovered pretty early on was that when you are looking at collecting data for a given feature, stream feature over time, you're basically going to create a record for every visit to that site. And we've maintained that data in a related table. So for a given feature, we might have 5 records in a related table that correspond to a particular site visit at a given time. Now, up until very recently, and we'll get to this later, there was no way to edit data, to make changes in related tables within the mobile application where we were using Collector. So we had this data, the data model in the database didn't fit or didn't work with our collection tools, ArcGIS Collector. So we had to do what us GIS folks do more often than we like. We found a workaround. The workaround is essentially a couple models that I'll just briefly go over here. I'm not going to go into the nitty-gritty of it because I didn't write it. But in any case, what we do is we've got the data in the database. That's the lowest blue dot on the lower left, and we essentially take the record from our related table. We pull it out, join it to a temporary version of the stream segment feature class, and then we end up projecting that into WGS so that we can take it out in the field. So we basically just create a temporary version of the feature class with only one record for the upcoming site visit. So all the other ones just stay in the related table. So we basically create a temporary file, a temporary feature class that we can use in the field so that we eliminate the issue of multiple one-to-many records within the data set. Okay, so once we had the data sort of prepared to do that, then we created a mobile collection application. This is just using sort of the default ArcGIS collector template. We're going to probably change that up and make some modifications to it once we get to a real production mode. We're still more in proof of concept phase right now. But what you can see here, we've got the GIS, the stream segments that are shown up there, highlighted in cyan. And this is where the folks will go out and to their site, and then you see the data here in the bottom. These are all the various fields that they would collect. They can also use the app to take pictures. We've tested this in an online mode where we've got a stable data connection, and it works fine. It's really amazing how quickly the data goes from the app, from the device you're holding, running the app, into the database. It's just a matter of seconds, and that includes pictures and everything. So that is really neat. That's been very encouraging. Yeah, the app itself is pretty simple. It's basically just find your stream. We have not enabled spatial editing, although we could, because they really only need just to collect tabular data in the field. So we don't want them to inadvertently reroute a stream in the database, and who knows what would happen to that. But anyway, so once we're so here we see a pop-up where you've got a series of the attributes there with drop-down menus, so that people can just kind of select, tap. Makes it a little easier to avoid having to use the keyboard. And then once they're out in the field and collect that data, and we sync back to the database, then all we do here is we take that related record and that temporary field collection layer, we strip it out and just put it back in a related table. So we're just going to basically build the related table as we go forward. So it works pretty well, at least within the test scenario that we've built to this point. These models are pretty straightforward. If you've got specific questions about them, then we're happy to share you more detailed information later. Okay, so some of the ongoing challenges with this project. First thing that we were really excited about was how ArcGIS Collector 10.3 was going to enable offline editing, and we have not been able to get it to work so far. So if anybody has, see me afterward. It seems to work okay. We go in and we select we click the download button. Once the app has been created and ready to go, and it fails. So we haven't figured out why it's failing yet. It either has to do with the base map that we're trying to offline or the actual stream data. But that was just last week that we were trying to troubleshoot that, so we're not there yet. But hopefully it will work, and that'll make it really great, because then you don't have to have a data connection. Then you could be out in the middle of nowhere, no Wi-Fi, no cell signal, collect the data. As soon as you get back online, either Wi-Fi or mobile, it'll sync it back up. That's the theory behind it, at least. The other thing is the models are working well, they're running fine, so we're going to just write those out to Python, and so we can automate the process, so we can just basically just run script to pull the information out, and then run another script once the data is collected. Lastly, the issue of ArcGIS online logins. We don't have an ELA, so we've got a limited number of logins. We can't give one to every stream volunteer. So right now, our plan is to have a shared login that they'll likely not be out in the field at the same time. So I don't think that'll be an issue, but we'll see how that works with a shared login for the stream volunteers. All right, here's the thing I alluded to earlier. Last week, as we published a blog post about you now being able to edit related tables within ArcGIS Collector. So that's encouraging. But I think our workaround is still relevant, because for a few reasons. You have to be using ArcGIS Online Services, so if you're trying to serve your feature service out from your local ArcGIS server deployment, it doesn't work yet. It's supposed to work with the next version, but it's not working currently. So that's another reason, or that's a reason that this approach is probably still relevant. The other thing is you must either use ArcMap or the Collector app. You can't do it through the web. So I suspect we're going to have some volunteers that aren't going to want to use a device in the field. They're going to want to go out with their paper. And if they do so, then we want them to go back home and basically pull up the app through the web browser and enter in the information manually if they choose to do so. So they're either going to have an ArcMap license or they're going to have another app installed to do that. So you can't do it through the browser now. You can't edit related tables through the browser. So again, this approach will eliminate that issue. And then lastly, I don't know, it may be that because there's another level of complexity, we've got an attribute table and then a related table related to that. It may make it a little more tricky to find the fields that you're trying to enter. Don't know, I'm just speculating on that. And that's just a link to the article on how to edit related data. So I'm hoping that soon enough it'll be worked out and you won't have to have this approach, but we'll have to have this approach. But in the meantime, I think it's working pretty well. And be interested to see how it goes once we get into more of a production mode. So I think that's it.